So the geometrical isomerism is due to the different planes the molecules are present. So we always check the heavy groups, like which side we have heavy group. If heavy groups are attached to the same side, we will use the term, you can say Z butene or you can say cis butene. Heavy groups are on the opposite side, so you can say trans butene or you can also say it is E butene. Now, as you can see, you have a compound 1,2-dichloroethene. So we have 1,2-dichloroethene. For this 1,2-dichloroethene, when you check the priority group, so chlorine because it's having a greater mass, 35, average atomic mass is 35.5. So chlorine is on the left hand side, chlorine is at the top. On the right hand side also, chlorine is also at the top. So you can see when they are on the same side, so we use the term Z. So it is 1,2-dichloroethene, but Z1,2-dichloroethene. And what is the meaning of a Z? It's from German, Zusammen, which means they are on the same side. And you can see the chlorine, one chlorine is at the top, another one is at the bottom. So it is also from the German one. And Gegen, which is refers to opposite side. And cis and trans isomerism is a special case of E and Z. Basically, what happened? Look, when groups, identical groups, and are all the same side, we use the term cis. Like this is CH3, the heavy group is CH3, and heavy group is CH3. So they, the identical type or same type of groups are there. So I can say it is Z butene, or I can also say it is cis butene. And if identical groups are there, CH3, the heavy group, and another CH3 also heavy, they are on the opposite side. So I can say E-butene, or I can also say trans-butene. But for example, if the heavy groups were different, like here the heavy group is CH3, but here the heavy group is not CH3, it is C2H5. Example. So both in this case, the heavy groups are on the same side, but the type of the heavy groups are different. So I cannot use the term cis in that case. We use Z, the name will be there 1, 2, 3, 4, 5. So it will be Z pen 2 in, not cis, because cis is a special case we use when the two substituent groups are same. Is it clear? In what case we can use, like in this case, because the substituent groups are same, so we can use cis or we can use Z, because the substituent groups are same and they are on the same side. But if substituent groups are same and the opposite side, we can use E or trans. But if the substituent groups are different, totally entirely different, then we cannot use the cis or trans. In that case, it is only Z or E. Is it clear this point? The geometrical isomer of alkenes. So example, if I was having fluorine and chlorine, so in this one I cannot use the term cis. I bound to use Z, because the heavy groups are on the same side, but the nature, the substituent group are different type. That's why I will only use the term Z. I cannot use the term cis. Same thing if this was bromine and one is chlorine. So heavy groups are on the opposite side. So if heavy groups are on the opposite side, I cannot use the trans. Why? Because the substituent groups are different types. Like one is bromine, another one is chlorine. So if substituent groups are of different type, we do not use that. Is it clear at this point? Any doubt? Then the reactions of alkene. In this case, you have to know the overall equation as well as the final result, the product. So example first, reaction of alkene with hydrogen. Alkenes undergo addition reaction. When we call them addition reaction, we have only one product. So you can see ethene plus hydrogen, it gives ethane. So what happened? One of the double bond will break, one hydrogen attached to first carbon, which is having a double bond, and the second hydrogen attached to a second carbon, which is having a double bond. So ethene plus hydrogen result in a formation of ethane. What are the condition? The reagent, the chemical which we use, hydrogen, we use nickel as a catalyst, and the type of reaction is called addition or reduction. Because the reduction also means addition of hydrogen is known as reduction. That is why it can be categorized as reduction or it can be categorized as addition. But the second most important thing is the mechanism. Mechanism means how this reaction proceed. Like first thing is to write a product, the second thing is the mechanism. So how this reaction proceed, basically the mechanism of addition reaction. Alkene plus hydrogen. So in exam as well, you will find this question, a common question, like show the mechanism of addition reaction when any alkene reacted with hydrogen. So you can have any alkene, you can have a symmetrical alkene or asymmetrical alkene. Like example, C, I'm taking ethene, or say propene. I'm taking, so propene 3 carbon. This is known as electrophilic addition reaction. Why we call this as electrophilic? Look what happened. It is reacting with hydrogen. Hydrogen means H2. So between the hydrogen atoms, there is a single bond. The two within the hydrogen molecule, there is a single bond. So this is that hydrogen molecule which is having a single bond. But what happened? Due to higher electron density, due to the presence of this pi bond and sigma bond, like this region you find more electron. So these electrons repel this electrons which are shared between the two hydrogen. So due to this repulsion, these electrons, because the like charges repel, so these electrons are shifted towards the hydrogen which is away from the double bond. So due to this shifting of electron, one of the hydrogen will become partial negative and the other hydrogen will become partial positive. Why this happen? Normally, look, for hydrogen, because they have two hydrogen atoms, when they share the pair of electron, they have equal tendency to attract the electron, so evenly distributed. The electron is evenly distributed between them. But due to as the molecule collide with each other, so this double bond, which is present in alkene, repels the hydrogen single bond, and one of the hydrogen electron pair is shifted more towards that become partial negative, and the other hydrogen will become partial positive. And what happened? So the part which become partial positive is attracted towards electron rich side. I'll use another color so you can identify the attraction. So the hydrogen which is partial positive is attracted towards electron rich side, and the hydrogen which was having a partial negative take both of the electrons. So when this hydrogen take both of the electron, then what happened? The second stage, the double bond will break. So this hydrogen can be attached with the first carbon or with the second carbon. So example, for first possibility, it is attached to the first carbon. Okay, this hydrogen. I will use the same color so that you can recognize like which hydrogen. So this is a hydrogen which is attached, and the double bond break because one of the electron pair is used to form a bond with hydrogen. So the double bond will break. As a double bond break, the central carbon now will get a positive charge. And why it get a positive? Because both of the electron, like this one electron belongs to left hand side carbon and the one electron belongs to right hand side carbon. But both of these electrons are taken by the left hand side carbon to form a bond with hydrogen. That's why there is a positive charge. This is an intermediate. Then what happened? The hydrogen which is having a negative charge, this hydrogen now will get a full negative. Why it will get a full negative? Because it took both of the electrons. So it will have two electrons. One belongs to this hydrogen, another one it took from the other one. So and this negative charge is attracted towards the positive charge. So it will form a bond, and this will result in a formation of alkane. So alkene basically converted into alkane. And there's a bond between carbon and hydrogen. So this is what happened. But this is one possibility, that when the bond will break between the carbon and carbon, the double bond break, the left hand side can have a positive charge, or the right hand side, the carbon cation, can have a positive charge. This is one possibility. Then what is the second possibility? Like this is the first possibility, that right hand side carbon get a positive charge. What is the second possibility? That left hand side carbon may get a positive charge. This is called a carbon cation. And for this one, hydrogen is attached. and then the hydrogen ion, the negative ion, that's attracted towards this positive, and the final result will be same. But which one will happen majority? The major one is the first one, A. Why major one is A? Like if I say when the carbon cation is formed, it can form carbon cation A, it can form carbon cation B. But which one majority will form A? What is the reason why majority will be A? Because when the carbon cation is surrounded by alkyl groups like carbon chain, this carbon cation, how many carbon chains are attached directly to it? Two. For this carbon cation, only one carbon chain is directly attached. Like there are two carbon in the chain, but directly attached is one carbon. So which one is more stable? The carbon cation which is surrounded by more alkyl groups is more stable. So the carbon cation which are surrounded by more alkyl group, you can see two alkyl groups or two carbon chains are attached. Here one carbon chain is attached. So this majority for major, this will happen. This will happen for minor. Means for some of the molecule will undergo bond breaking like this, but most of the molecule or majority of the molecule will break in this manner. Is it clear the mechanism of electrophilic addition reaction in alkene with hydrogen? So alkene plus hydrogen, this will result in a formation of alkane. And when the carbon cation, the intermediate form, it has two possibilities, like the left hand side carbon will have a positive ion, the right hand side carbon may have a positive ion. But how you will know which one majority of them will break? The one in which the carbon is surrounded by alkyl groups, more alkyl group, is the major. Is it clear the mechanism of electrophilic addition? I will explain mechanism of each so you will be used to it. Like you will find it's a similar thing. This is the first one when alkene is reacting with hydrogen. That was a mechanism. Now the second reaction example, when alkene is reacting with bromine. So when alkene is reacting with bromine, for bromine double bond will break and the two bromine atoms added. So the result will be 1,2-dibromo. Ethane will be there. If it was propene, then it will be 1,2-dibromo propane. But how the mechanism, how this reaction proceed? These are the reaction condition. The reagent is bromine. Ultraviolet light is not necessary. It can happen at a room temperature. Mechanism is electrophilic addition. Electrophile is bromine, partial positive, and type of bond breaking is heterolytic. Heterolytic means when unequal distribution of the electron, it result in a formation of charge. Example, so mechanism for electrophilic addition. When alkene is reacting with bromine. Now what happened? I can take any alkene, like example, I'm taking propene plus bromine. So prop means 3 carbon. So I will draw 3 carbon atoms in which the first two are having a double bond. What is bromine? Bromine is Br2. So if identical atoms, a covalent bond is formed between the identical atom, so the bond distribution is uniform, like evenly distributed. But what happened? How the molecules react by collision? So as bromine molecule collide with alkene molecule, the electron rich side, the presence of the double bond, so they repel this bromine single bond. And due to this repulsion, what it create? It create a partial positive on the bromine and partial negative. Why it create this? Because the electron pair is actually shifted more towards a bromine which is away from the double bond. So as the shifting becomes non-uniform or uneven, this result in a formation of partial positive and negative. Why partial positive and negative first? Because the bond does not break right now, it's only distributed. So what happened? This partial positive bromine is attracted towards the electron rich side. When it is attracted towards the electron rich side, it will form bond with one of the carbon, and the shared electron between the two bromine, that is taken by the bromine which is negative, partial negative. So what will be the result? Again, two possibilities are there, major and minor. So maybe the first carbon attached with the bromine, if first carbon attached with the bromine, then the second carbon will form a carbon cation, or what is this is one possibility. What is another possibility? Maybe the first carbon will form a carbon cation and the second carbon bromine is attached. So which one majority will happen? So how to identify? Check the carbon chain which are surrounding the carbon cation. So for this carbon cation, how many carbon chains are there? One directly attached, two. For this carbon cation, only one carbon chain is attached. So which one is more stable? Like which one will be major, A or B? Which carbon cation will be major here, A or B? So majority of them in carbon cation, when it is surrounded by more carbon chains, it's not about long carbon chain, it's about more carbon chain. So this will be our major and this will be minor. Then what happened? Because one of the bromine which got a negative charge as it took both of the electron, so that bromine attracted towards the carbon cation and result in a formation of the final product, which is 1,2-dibromopropane. So in this case, we have the same product because the same reagents are there. Even we follow path one in which B is formed and or A is formed, the result, the final result is same. But you have to identify the major and the minor intermediate which are produced during this reaction. Is it clear? The mechanism, you can see it's a similar mechanism, only The hydrogen, first one was hydrogen, now it is bromine. But the similar way they react with each other. Is it clear, the mechanism of electrophilic addition reaction? So you can see in this case that when bromine, it's a reaction of ethene plus bromine, but in this one we don't, both carbon, like when ethene is there, it is a symmetrical alkene. For symmetrical alkene, like the first carbon can have a form a carbon cation, or the second carbon can also form a carbon cation, but both will be same. Why both will be same? Because you can see, if this is a carbon cation, only one carbon chain is there. If the first one is a carbon cation, one carbon chain is there. So in this case, there is no major or minor, it will be same. So first, that carbon-carbon double bond repel the bromine bond, so create a partial negative and positive. Keep in mind the directions of the arrow, which is very important. Direction is always from the negative center to the positive center. You can see where the electrons are taken, like the electron taken between the two carbon to bromine, and the other one bromine is taking both of the electrons, and then it is using this lone pair to form a bond with the carbon. If it is reacting with hydrogen bromide, so if propene plus hydrogen bromide, prop means 3 carbon, when there is hydrogen bromide, because hydrogen bromide is already partial negative and positive. Why? Because bromine is having a greater attraction towards the electron pair, more electronegative. So originally it is partially positive and negative. So, and it will become more partial positive and negative when it collide with a alkene. So even there is no double bond present, but it, in this case, in HBr, it will be partial positive and negative from the beginning, because it is formed between the two different atoms. The previous, it was initially it was non-polar, like no distribution, but when it collide, it become partial positive and negative. But in this case, even if it does not collide, it will be partial positive and negative due to different bond. So electron, carbon, one of the carbon take an electron to form a bond with hydrogen, and bromine will take both of the electron. So the product, the intermediate, you may have first carbon may have a positive charge, the carbon cation, and the second one, hydrogen, is attached. Or like this is a hydrogen which is attached. Or the second possibility, the first carbon will have hydrogen and the second will have carbon cation. So this was a hydrogen which is attached to carbon, and this is a carbon cation, the central one. So which carbon cation is more stable, A or B? Which carbon cation is more stable? So B is more stable. You can see surrounded by more carbon chain. This is one carbon chain. Then bromine, which is having a lone pair, form a bond. The bromine, which is having a lone pair, form a bond. But in this case, you can see the products are also different. Like when bromine is attached to the first carbon, so it will be 1 bromopropane. But when bromine is attached to the second carbon, it will be a new product, that is 2 bromopropane, like isomers of bromopropane. So sometime they ask, state the major product and the minor product. So how to identify the major and the minor product? You just identify which one is more, like which one, as we identify the intermediate. So intermediate A was a minor and intermediate B was a major. So if the major intermediate is there, so what will be the major product? If they ask like which of them, which product is more, 1 bromopropane or 2 bromopropane? So which one will be greater here? In this one, which one is a major product? We have 1 bromopropane and we have 2 bromopropane. So 2 bromopropane will be a major product because the most of the intermediate consists of carbon cation, which is surrounded by more alkyl group. That's a major intermediate. That's why most of the product will form due to this major intermediate. That's why 2 bromopropane is more of as compared to, so this way, if they ask which one is the major product, so the major product will be 2 bromopropane and the minor product will be 1 bromopropane. 1 bromopropane will be there, but that will be a minor product. Is it clear? So when viewed to you can see this is propene, or say butanene. So butanene is reacting with hydrogen bromide. The carbon will form a bond. It can form 2 intermediates. The first carbon may have a positive charge, the second carbon. If first carbon having a positive charge, so only 1 carbon chain directly. If second carbon is having a positive charge, so 2 carbon chain. So can you identify which one is major product, A or B? Which one is a major, like the major intermediate? So A will be major, and that's why most of the product is 2 bromo butane, and minor product 1 bromo butane is there. Is it clear about the mechanism of electrophilic addition reaction in alkenes? So today we started alkene. First we discussed so we started alkene, and first we discussed the formation of sigma and the pi bonds. Then we discussed the mechanism of electrophilic addition reaction in alkenes. Any doubt related to the class today? We will continue this topic next class and finish unit 1 next class and do the past papers. Any doubt related to the class today? Any question or a doubt? Okay, so I'll end this session if no doubt and share the recording with you.